question number 7, we're really just going to try to tie together pretty much everything that we should know at this point about exponents. I expect you to know the basics of exponents from your first algebra class, and I'll try to tie in extra things about exponents that we've learned in this class, namely the things about negative exponents, which might be brand new, and the thing about zero exponents, which again might be new, because we've done those things in this very packet. The other rules of exponents that you might hear me touch upon are things that I'm going to assume are basic foundations from past classes. But as I reiterated in the previous video in this playlist, if these things are not foundation for you, if you really don't know some things about exponents and you feel like you missed something in a past class, please reach out and get some help, because we can't build on a weak foundation. It's like building a building when you don't have a solid foundation to build upon. Whatever you build on top of that crumbly foundation is almost sure to fall down practically immediately. There's no point in building if the foundation isn't solid. So again, take the time to make sure that you have a solid foundation on exponents before you go too far in this lesson, because otherwise we'll build on something that I don't think is going to help us in the long run. In any case, let's take a look at a few examples, starting with letter A, so that we can see how our rules of exponents are supposed to help us when we have some clearly complicated problems to solve. In number 7, letter A, we have 3 variables, x, y, and z. They're not like terms, and it is important to note that exponents and the rules of exponents generally only apply when we have like terms. So x, y, and z are basically like 3 completely separate entities right now, and I'll have to treat them as such. Some people draw boxes, some people don't, but it's just worth noting these are meant to be experienced as 3 completely separate things. Now, one thing we know is the rule of negative exponents. We know that x to the negative 4th as a standalone problem is very similar to the rule of negative exponents that we've already discussed. And I'll put my little notes back. Negative powers, we already have that rule where we can flip the base and make the power positive. So I'm going to think about x to the negative 4th in that context. I'm going to flip the base. Now that might seem weird because x isn't a number, but that's okay. X is still over 1. You can think of it that way. So flipping the base becomes 1 over x. Make the power positive. That's becoming x to the power 4. The y itself has a power of 1. By default, if you don't see a power on something, y is to the power of 1. That's not a negative power, so I'm going to leave y alone. I'm not going to do anything with that. But z has another negative power, so I'm going to, again, apply my rule, flip the base. It's currently z over 1, so the reciprocal is 1 over z. And then make the power positive, so that becomes power positive 5. Now this does involve a little bit more simplifying. This is not exactly nice looking, but I can deal with this. So I have 1 over x to the power 4, which means I have 1 over x times 1 over x times 1 over x times 1 over x 4 times. And if I condense that or clean that up a little bit, 1 times 1 times 1 times 1 is 1 over x times x times x times x is x to the 4th. Now you could have also taken a bit of a shortcut there and said to yourself, well, 1 to the 4th, or on the top is 1, x to the 4th on the bottom is x to the 4th, and you can make your life a little easier. Then we have y to the power of 1, then we have, unchanged, 1 over z to the power of 5, which is like 1 to the power of 5 on top, that's 1. Z to the power of 5 on the bottom is z to the 5th. So it's looking better, I guess. I don't really know what better is supposed to look like. I mean, when it said simplify each expression, I'm not really sure what that means. So I'll sort of fill in the gap for you just in case you too had that thought, like, what does simplify mean? Simplify generally means get the exponents to be positive. And this now has all positive exponents. So we have, in essence, simplified. If you're arguing that this doesn't look very simple, one additional step that you should consider is to do what I call cleanup. Cleanup is where you try to multiply and condense things together so that it has only one expression in the answer space instead of 3 separate expressions. So if I think about this y is over 1. I could think about this as 3 fractions just multiplying themselves together. 1 times y to the power of 1 times 1 in all the numerators is just going to be y. Y to the power of 1 technically, but you don't even have to write the power of 1. And then on the bottom, x to the 4th times 1 times z to the 5th is x to the 4th, z to the 5th. So that looks a little bit more cleaned up, for sure. But here, perhaps most importantly, is the one thing that I want you to be able to take away from this example. I walked through in painstaking detail all the things that you can do to clean this problem up. But there probably could have been a faster way. And I'll ask you to look with me for a second to see if you can spot a bit of a shortcut that we could have taken. Remember that idea that anything that has a negative exponent reciprocates its base? The base flips over? Well, when we think about the flipping thing, you may actually want to think about the entire question as having been a fraction from the beginning. So instead of flipping each individual item in the way we did, you could think of it this way. If you think of the problem as one big fraction, this whole original problem was over 1. All of the individual pieces were over 1, but the whole thing could have been over one gigantic 1 from the beginning. When we say flip anything that has a negative exponent, we can actually say to ourselves, hey, x to the negative 4th, that has a negative exponent. I'm going to flip it. It's currently on the top of the giant fraction. I'm going to flip it to the bottom of the gigantic fraction. Because what that essentially does is kill two birds with one stone. You'll relocate the x to the bottom, which is where we know it's going to end up in our answer anyway. And we're going to take care of the negative exponent, making it positive, which we know is going to happen in our answer anyway. The z to the negative 5th is going to do the same thing. It's currently on the top of the problem in the original expression, but we know it's going to reciprocate, and we know that the exponent is going to change to positive, so I can do all that in one step. Flip it to the bottom of the gigantic fraction bar, and make it a positive 5 instead of negative, and boom. You've done the reciprocating, that's the flipping, and you've done the changing the exponent all in one step. Now the only thing that's not going to change is the y, because its exponent is already positive. Y to the power of 1 is still y to the power of 1. It's not going to move. So you notice how it was on top of the giant fraction bar to begin with? It's going to stay on top of the giant fraction bar, and it's not going to change at all. So if you wanted to take a shortcut, you could essentially think about the flipping without actually showing all of the individual steps. Compare my work on the right-hand side of the screen to my work on the left-hand side of the screen. You can clearly tell the work on the left-hand side of the screen was done through talking, not by writing, but it gave you the answer without having to do all this intermediate writing, and that might be a big time saver. So in case you're wondering how you could apply that strategy, that maybe you want to think about using that strategy, check out letter B and see if you can apply the strategy in this one. In letter B, think about what needs to flip versus what needs to stay. That's usually my criteria. Negative exponents need to flip. So x to the negative 7, that's a negative exponent. It's going to have to flip. Y to the negative 2, that has a negative exponent. That's going to need to flip. But then the other two aspects that don't have negative exponents, y to the 0, x to the 4, those are going to stay. So here's what I mean by flip and stay. Think about the giant fraction bar that already exists in this problem. We can see it there. It's straight through the middle of the problem. Y to the power of 0 is not a negative power. It's going to stay right where it is. X to the negative 7, well, that has a negative power. It's going to flip to the opposite location. So it's going to flip to the bottom of the fraction bar and become x to the positive 7. I don't care where. It just needs to go on the bottom. So now if I think about what was already on the bottom, x to the 4th is not going to go anywhere. So notice how I kept it on the bottom. It's going to look a little messy at first. I'll clean it up in a second. But y to the negative 2, oh, that's a negative power. It's currently on the bottom, so I'm going to flip it to the top. That's the reciprocating part. And I'm going to make the exponent positive. Now that I have this written, it looks kind of awkward, so I'll clean it up. But notice how quickly that took care of all of my reciprocating. The parts that don't reciprocate, the parts that don't flip, stay exactly where they are. Y to the power of 0 is still on the top. X to the power of 4 is still on the bottom. And the parts with negative powers flipped. X to the negative 7, there it is now on the bottom. Y to the negative 2, now there it is on the top. So flip just means it changes locations and the exponent becomes positive. If I clean this up, let's think logically. Y to the power of 0 is 1, because anything to the power of 0 is 1. So 1 times y squared on the top is just y squared. On the bottom, I have x to the 7th and x to the 4th. If I combine all those, that's 7 x's, 2, 3, 4, 5, 6, 7, and 4 more x's, 1, 2, 3, 4, which, if I count them all up, is a total of x to the 11th. And some people would say, oh, Herbert, why did you write that out? You're so silly. You could have just done 7 plus 4. Totally true. If you know your rules of exponents, you don't have to write everything out. But nevertheless, that is a cleaned up, simplified answer. A cleaned up, simplified answer should have one single fraction, if possible, with all of your variables combined together in one big fraction, and all of your exponents should be positive. So that's actually the key. When it says simplify, every exponent should be a positive exponent. That's how you know your answer is simplified, if all your exponents are positive. So see if you can apply this strategy to a couple of select questions. Try, if you can, questions like letter D and letter E. If you're not sure, then in the next video I'll go over another example so that way you can see some of these in action. But I have a feeling that once you get the idea, you might be able to start skipping some of the videos and doing some of the problems on your own, because now you already have enough information that you can sort of pick up with your momentum. In any case, I'll do one more example in number 7 in the next video, but if you feel like you've got it, then skip that next video and move on to number 8 and try to finish the page without me.